Hey everyone, Dave here. So, resuming back with the NEP-5, I want to go and secure this initialize method here and start to talk about how to know who is calling our code here. So one of the things here with this initialize method is anyone can call it, and every time we run it, it's going to give the owner 1,000 tokens here. So technically we could have 1,000 tokens. We could initialize this contract, we could transfer the 1,000 to another account, and then we could call initialize again and get another 1,000 tokens. So not really the greatest setup. But first, I don't want anyone else to call this method here. So we could make it so we could only call this once. But what if someone else ran it? Now, in this case, it's going to go to the owner. That's fine. But we may want to deploy our contract to the blockchain, especially when you go to production, and maybe not initialize it the second it's deployed. You may want to wait a week, a month, until conditions are right to launch your token. And you don't want anyone just to be able to maybe call this. And it would be fairly trivial to write something that would scan the blockchain for new contracts and call different methods on it and just muck with it. So what we're going to use is runtime.CheckWitness. And we're going to pass in the owner. So if runtime.CheckWitness owner, so what that is going to do is say, is the current user running this script equal to what is passed into here? So if we run this as the owner, then this is going to succeed. So we can put that in here. So now only the owner can run this. Now, that's pretty much it, I guess, on that. I know this CheckWitness is a little bit of a weird wording and can kind of trip people up, but here what we're going to do is you know what? We're going to put in a flag here of initialized true. And initialized is going to equal storage.get. And we're going to pass in initialized. See if I can spell that. I don't know if there's an extension method here to make it a Boolean. Okay, so let's just simplify this here. Basically, we're just going to check if the key is there. Why is it opening a file? Must have hit a shortcut key there. And it doesn't like storing Booleans there, so we were just going to store the string in there. So what we're going to do is we'll store the initialized string. So basically this key will now exist. And so the first time we call this, initialized will be null, and it will run, and then the second time it will not run. Okay, that is built, and switch over to the debugger now. And now I will blank this out here. So if I look now at storage, oh, yeah. Let's step through this. I will show you something that is interesting here with the debugger if you are not familiar with it. Here we do our CheckWitness to see if we are who we say we are, and we exited. This is because that is the default behavior of the debugger. So if we go to run under options, CheckWitness, we can tell it to return true or false. So now if we say return true, it would have always return true when CheckWitness is called, and it still didn't work. Just step through that. Oh, again, sorry, it's early in the morning. If initialized equals null, we want to run that. Sorry, folks. Anyways, you can see that it did go into this CheckWitness here. So the other thing I want to do while we're here is that this is getting a little unwieldy to work with, having everything in our main method here. So we can actually pull this information out to a method here. So I'm just using ReSharper to do that. I'm just going to call it init. And I'm going to do the same for balance of. So here I passed in the whole args. What I'm going to just refactor this a little bit. This is going to be now a byte array, and that is our address. So that should keep things a little bit easier to read in our main method. Get rid of the braces as well. Okay, let's build that and run it, just so we're not bouncing all over the place. Wait for this to build. Okay. And I've got to go back to options, always true. Okay, initialized the content. So this is the string, the hex encoded version of true. T-R-U-E. And quotes maybe? That's interesting. It has that many more bytes, but it doesn't really matter for the sake of this. Because now if we run this here as the debugger, just to make sure, initialized is now has a value in it, so it will not let us initialize again. So we have secured that method. Okay. So we're actually getting fairly close. The last thing we have to do here is the big method is transfer. So transfer is the method that gets called that allows us to move funds from one account to another. Right? So transfer is the amount of tokens from the from account to the to account with the amount. So we're going to do a little bit of validation here on the from and to address and make sure that the amount is greater than 0. So it's nice that the NEP-5 protocol has been kind of updated to have some of these things in here, because if you didn't do some of these things, you could find some interesting little security holes in there. So I actually just, the nice thing is the NEP-5 protocol, I can just copy that signature right from there. So we're going to return transfer, and then the first argument is a address, which is a byte array. Second one is also byte array, so args1, the 2. And then the last one is a big integer. be, oh, there my sense came up though. Big integer, 2. So we're going to have lots of checks in here. Dot length is not equal to 20. Maybe I'll make these a little more descriptive. Again, these exceptions don't really bubble up that I'm aware of. And if amount is less than 0, invalid amount. I'll uppercase that to be consistent. So there we've got our basic validations in there. We don't want people to pass in a negative amount, obviously. If I said I'm going to transfer negative 500 from me to you, and you had 500 tokens, actually, it wouldn't even matter if you had 500. Suddenly I would have plus 500 in my account, and you'd have negative 500 in your account if we didn't put this check in here. So that's a very good check to have. So I want to kind of wrap that up here because I feel that the actual functionality to do the transferring is, we've got a lot more checks to do here and a lot more logic. So I'll carry that on the next video, and I look forward to seeing you there.